Hello everyone, welcome to this session. Today we will see how to create Lambda function using Eclipse. We will also see how to use AWS CLI command. Using this command we can build our project, run our project in our local machine. We can also deploy to the AWS server. So AWS Lambda is a serverless compute service where we can deploy our project and we no need to worry about setting up the server. When we say serverless, uh, as a developer it is serverless for us, but backend AWS will deploy our project into the server. Let's say if I'm creating my project using Java or Python or Node.js, or AWS will identify that and it will allocate the resources as per our project, and whenever we execute our project, whenever we make a call to the project, our project will be executed as per the environment. So when we make a call, AWS will deploy our project to, let's say if my project is on Java, AWS will run our project on JRE. So before creating the project, we'll have to set up our machine. So the first thing is we need to have Java installed in our machine, and as of today, January 2021, we will have to use either Java 8 or Java 11. So I have already installed my Java and my version is 11. So I'm using OpenJDK, I'm not using Oracle. Then the next thing is we need to install Maven. So Maven is actually used by AWS CLI command. So when I run SAM build, internally it will call Maven package. So my version is 3.6.3. So the next thing is we will have to add AWS toolkit. So I have already installed AWS toolkit into my Eclipse, but I will show you how to install toolkit. So first thing is we'll have to go to this link. I will copy this link in the description so that you can copy it from there. So you'll have to copy this URL where the plugins are available. Then we'll have to install it by going to install my software, AWS. So these are the tools available. So if you want, you can select all the tool and you can install it. I have not installed Android development kit. So once you install, you have to restart the Eclipse. So once you install the plugin, we will see this icon. So here we can create Java project, Lambda, or we can use step functions from here. Let me bring this view to the front. Okay, so from this IDE actually I can connect to my AWS account. So to do that, we'll have to create IAM user. So using that user will connect to my AWS console. For that I will go to IAM. So these are my recent visits, but if you don't find that, you can find it from here. I'll go to users, I'll create a user, let's name it as Lambda user, and I'll give programmatic access so that we'll receive access key ID and secret access key. Then I will attach policies and I will give admin access so that we'll be able to access everything under my account. Ideally we won't be giving admin access, but for this testing purpose we'll give the access. I'll ignore the tag, then create the user. So here we'll receive our access key ID, copy this access key ID, and let's go to Eclipse. Under preferences, see here we have different options, right? So this is the AWS toolkit. I have already configured my user here, but I will show you how to do it. Let's create it as Lambda user, copy access key ID, and also copy the secret access key, then apply and close. So once we add our user here, programmatic user, we should be connected to our account. Let's say if I want to create SQS, I can create it from here. I don't have any SQS in my account. Let's say if I want to create S3 bucket, so as of now I have one S3 bucket here. Let's verify that. So this is the S3 bucket. I can create one from here. Let's say Lambda test some random numbers, because S3 is global, so we need to have a unique name. So this bucket is now created. Let's refresh, and the bucket is created here as well. I felt this one is more comfortable when we need to create a small buckets or SQS, but if you want to create advanced, then we can use CLI command. So once we configure Eclipse, we have created IAM user. Let's install AWS CLI. So I have already installed AWS. Let's see what is the version. Oops, AWS, I think it's version. No? Yeah. So I'm using, I've already installed AWS CLI. So if you want to install CLI, you can go here to this link. Again, I will copy this to the description, or you can directly search AWS CLI and it will take you the page directly. So this one is pretty straightforward. You can select your Windows, Mac or Linux and install CLI. So once we install the CLI, we need to add the programmatic user here as well, because the command line, from using command line, we need to connect to our account, right? So for that purpose, we will have to configure the same programmatic user from command line. So to do that, let me run configure. So the first thing is it will ask access key ID. You can either copy it from your user or you can copy it from here. So this is my access key ID. I have already given my ID. Then second thing is secret access key. You can get it from here. Then we'll have to select region name. My default is US East 1. Output is none. So we have added our IAM user to AWS CLI. So let's see if I can connect to my machine. Let's create the same S3 bucket from this command line and we will verify that. So the command is AWS S3 MB, then S3, then we'll have to give the bucket name. Let's say Lambda test 000 t. So the bucket is created now. We can verify it from here. Yeah, it's created 00023. So we are good with this connection. So the next thing is we'll have to install AWS SAM CLI. So AWS SAM is a wrapper for AWS CLI. It's a serverless application model. Using this we can create our serverless application, and the SAM CLI will take YAML as input file. Basically what we do is YAML is kind of JSON, right? It's based on indent. So I will show you how the file looks like, but I always relate YAML with JSON. Both are almost similar. So the SAM CLI is very useful when we are developing our Java functions, because we will write maybe 8 to 10 line of code, and it will actually create the whole environment. Otherwise we have to go to the portal, then we have to click different services to create those services. Instead SAM will create it for us easily. I will show you the YAML sample file in our later session. Before that we need to install the SAM CLI. So this is the URL for SAM CLI. Again, you can search it from Google, and you'll find the same URL. So you can select any link. I think most of us we are using Windows, and one of the reason, actually I'm not using Windows, and one of the reason is I need Docker to be installed in my system to run my project in my local machine. So Docker they stopped supporting Windows 7. They only support Windows 10. So I don't have Windows 10, and I don't want to upgrade my system. So I installed Ubuntu as dual system. So whenever I work on whenever I work on AWS, I will log into my Ubuntu. So the steps are pretty straightforward. If you are using Windows, you'll have to go to the Docker website, and you'll have to see if you're using Windows Pro or Enterprise or Education or Windows Home. Accordingly, you'll have to install the Docker. So once the SAM CLI and Docker is installed, you can come here. So I'm using SAM 1.15.0. So you can verify that your SAM is running. So the second thing is we need to make sure that our Docker is running. So I have already installed Docker. So my Docker version is 20.10.2, and my Docker is running here. Okay, so verify that your Docker is running, because we need the Docker to be in running state to test our application in a local machine. Okay, so now we will create a sample project. So the one of the advantage from AWS is they have provided some sample applications, and we can use those applications to create our first project. And I will use one of the sample project from them. So to do that, we'll have to use SAM init. So from here we can actually copy the project to our local machine. Let me increase the size. Okay, so here I will select the first one, the zip option. So as I said, they are only supporting Java 11 or Java 8. In my case it's Java 11, so I'll select 5. Again, you can use Maven or Kettle. I'm comfortable with Maven, so I'll select one. Let's name the project hello WRLD hello world function. So the project is being cloned from GitHub, and we can select which one we have to select. I will go for hello world now. So the project is copied to my local machine, so it's under Eclipse. So this is my folder, so my project is copied here. So this is our hello world sample project. So the YAML which I was discussing earlier, this file, we'll open it later. There are other two folders. One is event folder. This is a test file to run this project. It's a JSON file. We don't need to worry much about this for now. Then the second thing is the project folder, and we have POM because we are using Maven. I will open this from our Eclipse IDE. Then we have source, main and test. Inside test we have JUnit, and we have the main where we have our actual Java code. We will see this from our Eclipse. We'll open this project in our Eclipse later, but let's build this project using command line. So to use SAM command, we can use build. Sorry, I think I spelled it wrong. BYLD. So it's showing as template not found. It's because right now I'm inside Eclipse. I'm inside here, but my project is actually, my YAML file is here, so I need to go to this folder. So I will go to hello world, now SAM build. So if you see here, it is actually using Maven build command. So this shows that our SAM is working fine. Let's import this project using our Eclipse. So to do that, let's go to files, import existing Maven project. Then we'll have to go to the directory. I think it's here. So it will identify our POM, and it will create the project in our machine. It's okay. So this is my project directory. As you see, you can see the POM. So we are using 1.8. Then we need these dependencies to run our Lambda function. So this is AWS Lambda events, Java events, and Java core, and also we are using JUnit test, and we are our face is packaged so that it will be built. So this is our main application, and this is our Java program, sorry, Java uh, class. Don't get confused with this. It's very simple. What they're doing is they'll get input as an event. Okay, I think before that, let me show you uh, the structure of this project. So the project is it's very straightforward. So the front this is our Lambda project, and it will accept REST API REST call, and it will use Amazon API gateway. So the client will make a request to API gateway, and this gateway will direct our call to the Lambda function. So this Lambda function will actually use two other services. One is IAM role. So the IAM role is used by Lambda function to execute to access. Let's say Lambda function will actually write to a log, which is nothing but CloudWatch. So we need to provide access to this Lambda function to write logs to the CloudWatch. So it will create IAM role for that. I will show you in the portal once we deploy it to the AWS environment. But for now, you can remember AWS will create a role. It requires role. Let's say if AWS our Lambda is connecting to S3, then it requires that role, right? The same way in this project, it will write a log to CloudWatch. So we need to create a role. Second thing is actually we no need to create a role, but AWS will take care of that in this project. And the second thing is a IAM policy. So policy is nothing but, let's say in this case, Amazon API gateway is connecting to Lambda. So we need to give access to this API gateway to connect Lambda. So that will be taken care by this IAM policy. I will show you once we deploy this to the AWS environment. So here, this is our main function, main class. This is our main method, and this method will take input as API gateway proxy request, because the user is requesting from, because Lambda is getting request from API gateway, right? And this is context for the current execution. And this one, anyway, you know, we are expecting application JSON. Then this one actually, I think you don't need to worry about this, because they are just trying to, they have put some logic to get IP address. And the second, this will be the first value as output, and this will be the second value as output, and the message will be written as hello world in a JSON format. So this will get the IP address, this will get a hello world, and we are passing it as a response in the output message. We will actually create a very simple project in our later session, but as of now you can remember that actually we are passing some parameters from this function, and the main thing here is the package, the class name, and the method, because okay, I think my Maven project does not copied my YAML file, so let me copy it here. So this is my YAML file. Forget about this. This is description. Let me remove this. Even we know this one as well. and this is common for all YAML uh, configuration file. Our project, actually the one which I have shown you, this one, this entire thing is created with this, I would say, 16 line. So basically what it does is, we are saying that the resource, it's a type of serverless function, because we are using Lambda, so we have to uh, select type as function. Code URI is nothing but the folder. Let's say I have given this hello world function, so that it will find that okay, my project is under this directory. So the next thing is handler. So as I said, this is my package name. If you see here, this is my package name, and app is my class name. So this is my class name. Then we will give the method name here, so that the call will come to this method. And this is my Java runtime, and this is my memory. Even this is not required because we are not using this value. Then this is our event. So this Lambda function is attached with the event, which is nothing but Amazon API gateway. So this event, we'll name the event as hello world, and we are saying that event type is API, so that we are saying that it's Amazon API gateway. Then the properties, it's a REST get method, and the URL is hello. That's it. And we even don't need this for now, but I will keep it as it is, because using this we can get the REST URL. We have other way to get REST URL, but uh, for this one we won't go there. We'll just run the project and see how to run our REST. Okay, let's keep it as it is. So we have explained our YAML. Then the test is this one. It will look for the message. I think I no need to go to this JUnit testing. Okay, so let's first run using our CLI command. Then we will configure our SAM local configuration and run it in our Eclipse. Okay, so to run my project, I have to use SAM local invoke hello world function. So what it does is, so this is SAM local invoke is my command to invoke my project, and this is my project name. It's nothing but hello world function. Then if you see here, it took some time because it was trying to pull our image from Docker, and once the image is pulled, and it will copy that into the container, and it executed the project, and we can see this message. So as we said, this is JSON output. Message is hello world, and location is IP address. That's what I was explaining here. This function, actually they are trying to get a IP address from here. You can ignore that for now. So this one we can execute locally, but same time we can actually call, this is a the REST project, right? So the input is REST. So this is our get method, and this is our URL. So we can actually uh, run our we can actually make a call, REST call in local. So to do that, we'll have to use SAM local, then start API. So this will actually start our API, and our REST will be uh, installed locally, and we can use this URL to access our REST. So I'll copy this URL. This is our endpoint URL. I think I have Postman. You can either use Postman or browser as well. And my method is get. I will copy this here, and the endpoint URL is hello. Copy hello. See here, we received output from here. You can also run this URL from the browser because we are not passing any parameter, right? So here if you see each execution, it will give output here, but our endpoint is running here. So with with SAM local start API, we can execute, and this is output. Okay, hope you are good with this. I will close the execution now. So I think we have seen how to run our application using SAM local, and also we can use SAM local start API to run our to make a REST call. Okay, next we will see how to execute our project from Eclipse. So to execute our project from Eclipse, first thing is we have this YAML copied. Then the next thing is, I think the Maven did not copy the events. This will be the input file which we need to pass. So I'll copy this folder to my project. Okay, so we will have to set up AWS SAM local. So for that we'll go SAM local configuration and create a one. Okay, I think it's already set up. Okay, so I think I have some issue with the ID because of maybe I need to update that, but that's fine. So the first thing is, this is the configuration file for my SAM local. So I'll be selecting my project. This is my project. Then we'll have to select our SAM template. So we'll have to go here, then we'll select this template. Then the next thing is this will be Lambda function because we are running Lambda function. Then the event, as I said, we just copied the events folder. This is the JSON file. I will also show you how to set up the advanced setting, because sometimes this SAM local will not be set up here. So let me see, where is SAM? So my SAM is under this location. So if you are using Windows, it will be under programs. So you can copy that path and let's see if this is correct or not. Home Linux view, Linux view. Yeah, so the path is already set up for me. If not, you can uh, check where is SAM installed and copy that path here. And also make sure that you have set up the environment variables for Java, Maven, then also for Docker. So once we configure this, we are passing, this is nothing but we are passing input. Actually our application is not accepting any input, but uh, we have to pass this mandatory, so it will actually, you can put any file here, but we are just placing the file which we received from AWS. So we'll run the project here. So the build is successful and it is actually mounting the it's actually created the image for Docker and it has provided the output with this message. Okay, so the important thing is before we run the project, we have to configure our SAM first time. Hope you are good with this. Okay, so next we will deploy our project to our machine. So to deploy, uh, when we deploy first time, we need to provide some parameters so that the system will remember which region to select and other parameters. So to do that, let's run our deploy command. It's SAM deploy guided. So first time we will select this option. I think I spelled it wrong. SAM deploy minus okay, let's see what is the option we have. Okay, it's minus guided. Okay, so see here, it is showing us we don't have the configuration here, so we'll have to select our stack name. So stack is nothing but uh, when we deploy our project, actually it will be deployed into a cloud formation, right? So cloud formation will have stack is nothing but it will contain our whole project resources. So we'll name our stack as hello wrld world function. Then I will select my region as US East 1 and confirm resources, confirm changes before deploy. I no need to confirm. Then allow SAM CLI role creation. So this is where it will create a role for us. I will select as, then may not have author certified. Is it okay? Yes. Let's save it, and the file, let's keep it as SAM local itself, and let's keep it default. So if you check here, oh no, so it's creating the resources. It will take some time because it will have to create it will first create a cloud formation. So cloud formation is actually using CloudFormation, we can actually build our AWS environment. Let's say in this case, first it will create a CloudFormation. From there it will create a API gateway for us. So this is our API gateway. Then it will create a Lambda function, and it will create these roles and policies. Let's wait for some time. It will take some time. Let me increase the page. So the operations it's going to do is it will create Lambda. It will create a role for us. Then API gateway will be created for REST API. So this is the status right now. So these are the stages of stack CloudFormation. Okay, so it shows that we have successfully created the project. Deployed the project, and this is our endpoint URL. If you see here, I have not removed the outputs. The reason is we can actually get the API endpoint from here. So this is a dynamic value which will be created on the fly, and we can actually copy this URL and run this here. It should show the same result for us. First time it will take time because AWS is deploying our project to their environment. So if you see this is our server endpoint URL. Our REST endpoint URL, and this is output. Let's see what happened inside our account. So first thing is we'll see our CloudFormation. See here, we have created this. We are given this name. So this is our the stack, and this is stack name, and this is the same output what we have seen in the command. And these are the resources for the stack, and this is output same what we copied from there. That's the reason I have not deleted this output, this one, so that we can directly copy it from here. We have other way to copy as well, I'll show you, but yeah, if we keep the output, it's easy to copy from here. Then let's go to the Lambda function. This is our Lambda function, right? Yeah, 3 minutes ago. Let's go inside. Okay, so this is our Lambda function, and as I said, this Lambda function will take trigger from API gateway, and we'll not discuss this now. I will discuss this in our later sessions, but the one thing I wanted to show here is permission. So as I said, there is one role created, and this Lambda function can create log group, create log stream, and write to the log events. And also there will be one policy attached to this. This policy is nothing but we are allowing this API gateway to call our Lambda function. So the policies for this API gateway to connect to Lambda, and the IAM role is for this Lambda function to write the log. If you want to test this one, we can create a test case. Let's say T1. As I said, our project is not taking any input, so we'll keep it as it is. We will run the test, and here we'll see the test log. See, the message is same. We can see this log from our CloudWatch. Let's go to CloudWatch. There should be two logs, I believe. One is from this call and other one is from there. So this is our cloud stream, and this is my call, and it will show you how much it is built. So as I said, we have two calls here, and I'm not writing any sysout, or I'm not using any log4j logger, so I'm not writing anything into the log. These are the system generated logs. And the last thing I wanted to show here is API gateway. So this is our hello world function gateway, and it shows that we have one get method, and it is actually connecting to a Lambda function here, and it will get a response. So basically this is our client. Call will go to our API gateway. This will redirect it to our Lambda proxy. This proxy will contain our Lambda function. Lambda function will execute our program, come back, and send the response back to the client. We can also test it from here, as we don't have any input, so just click on test. We should be able to test it from here as well. Okay, so the entire this project structure is created with this template. Basically what I'm saying is only this, I would say 12 lines. We created Lambda function, and we created event, and we receive basic IAM role to write to our CloudWatch, and this is our project is. Hope this will help you to set up your development machine, and in next session we will actually create this YAML file, and we will deploy our project. Thank you for watching.